Thank you all for joining us today, and thank you, Scott, for being here as well. Welcome to the Center for Jewish History's Family History Today series of genealogy-themed public programs. My name is Moria Amit, and I'm the Senior Genealogy Librarian at the Center for Jewish History. The center provides a collaborative home for 5 partner organizations that together form the largest archive on the modern Jewish experience outside of Israel. In addition, the center houses the Ackman and Ziff Family Genealogy Institute, which is where I'm based, which strives to connect researchers to the wealth of genealogy resources at the center and to make family history accessible to researchers of all ages, abilities, and levels of experience, whether Jewish or non-Jewish. While the center remains closed, our genealogy librarians are still working remotely and are eager to assist you with your research. You may continue to engage with us in the following ways. Watch our weekly genealogy coffee break webinars for a brief dive into a specific genealogy topic every Tuesday at 3:30 p.m. Eastern Time on the center's Facebook page. You can also email us at gi@cjh.org. Again, that's gi@cjh.org to ask for advice on your research questions or to arrange a free genealogy workshop for your synagogue, senior center, genealogy society, or other community group. Lastly, I hope you had the opportunity to see the announcements of some of our upcoming programs before I began speaking. To learn more about these or other future programs, check out our program calendar at programs.cjh.org. And just a quick note on that, we will be having our next genealogy public program on December 3rd at 12 p.m., featuring guest speaker Serafima Velkovich from Yad Vashem, who will be talking about new developments and features in the Yad Vashem's Shoah names database. So I hope many of you will come back and join us for that one. A few quick technical notes. You may have noticed that your microphones have been muted and that the chat box has been disabled. That is intentional. To send us your questions and comments, you will be using the Q&A box today. You should be able to find that on the bottom or the right side of your screen, depending on what kind of device you're using. You're welcome to send in your questions at any time, but please note that our guest speaker will be answering your questions during the dedicated Q&A period at the end of the presentation. So with that, I'm going to introduce today's speaker, Scott Genzer, who I first heard at the International Association of Jewish Genealogical Societies conference this past summer. And I was really amazed by how he's brought us really into the cutting edge of genealogy, and wanted him to bring him here today to share those developments with you. And based on the fact that we have over 200 people here today, I can see that there's quite a lot of excitement about this. So with that, Scott Genzer is an amateur genealogist who has spent 2 decades researching his family tree. He is also the founder and manager of Mielec Yidden, a website dedicated to preserving information on the history and lives of the Jews of Mielec, Poland. And by day, he is a data scientist at RapidMiner, a software company based in Boston. So with that, please take it away, Scott.
Thank you. Thank you very much for the invitation to be here. And thanks to everyone who, on a very chaotic and strange day, has decided to take a break from the real world and learn a little bit about facial recognition in genealogy. So I'm going to just start ahead. I have a bunch of slides and I have some live demos with the technology. And then again, if you have questions, please put them in the Q&A box, and my friends over at the Center for Jewish History will help me field as many as possible. So just a little bit of prelude. This is actually a presentation that follows an article that I wrote in Avutenu back last fall. And so I just want to thank the editors of Avutenu for giving me the permission to go and use my article in these talks. And if anybody wishes to get a copy of it, you can contact me. My contact's at the end of the show. So I'll leave the last slide up and people can go and use that information there. And really this process started for me a a year and a half ago, I was thinking this morning. And what I'm going to sort of do is walk you through sort of a little bit of a story, and then I'll go into the technology. The story is like this. Like many of us, we all have piles of photographs. And I'm sure you do. I'm sure your photos may look like this. This is my family. Various great pictures of my grandfather and my great aunt and so on. And when we, as genealogists, have these photographs, really all we end up doing is putting them on a tree, just like this. And you may have software, you may do it with pencil and paper, but by and large, that's really where we end. It's really a real challenge to go and use these photographs for anything else besides, for lack of a better word, decoration, really. And yet we have tons of photographs, and there is such rich information in them. And so I was thinking about almost 2 years ago at this point, well, what else could we do with them? And so what if we could do more? So what I'm going to do is walk you through an example. This is a true story, and I'm going to walk you through exactly how I solved this problem, and then walk you through a few more examples. So this is a photograph that you see on the right that is part of a museum collection in Mielec, Poland, as was in the introduction. This is the town in a little bit east of Krakow, where my grandfather and grandmother on my father's side both came in the interwar period. And I've been researching my family for many, many, many years, and have been in contact with the folks there and with the museum. And they have lots of these photographs. These are portrait photographs from a photographer in Mielec, and we know they're Jewish families, but we don't know who they are. And so it's been sitting in this museum for at least 50 years that they know of. It's actually probably a 100-year-old photograph. And so they, in the collection, they want to know who these people are. And my answer initially was, I have no idea. But then I started putting on my data scientist hat, and I realized that we could use some technology to solve this problem. So we're going to work with this photograph for a little while and show you how I go about doing it. So the first step in using facial recognition, particularly with genealogy, is you need a lot of pictures. This is what we would call in the technology world big data. We're going to use a particular technique called machine learning. And the thing about big data is you need a lot of data. And so in the photograph world in genealogy, you need a lot of pictures. Because what we're going to do is we're going to basically ask the computer to look at lots of pictures and basically play a big game of concentration, trying to go and look at one picture, look at the other picture, and be able to look at thousands of pictures and say these two are a match. That's really what we're doing. So the first step is really to get a large collection of known people, so that when I can go and send the computer faces of people I don't know, the computer can then say, aha, I know that person because I saw that person 3,000 pictures ago. So that's what you need to do. You need to get a large collection of known people. At least this is how I did it. So, and then the question is, where do you find these people? And so the answer is, they're actually all over the place. It's just that, and I don't know if this is true for many of you, but it's certainly true for me, is that when I see these pictures in vital records, for example, this is an emergency passport application for Rosie Freemauer, and who's from Mielec. And the question is, normally we just take the picture and again, we just slap it on the family tree and call it a day. But if you actually think about it, these pictures are quite normal to see as part of vital records. So again, US passport applications. Here is another set of records held by the US Holocaust Museum. This is I believe the Krakow census that was done in 1941, if I'm not mistaken. So once again, normally as genealogists, we take the address and the date and so on, and the picture at the bottom is nice, but not always used to actually do research. So what I'm doing is I'm grabbing this picture and I'm saying, if you look on the right-hand side here, is I'm starting to name these files, and this is extremely important. I name these files in some way that is somewhat structured in a way so that I can somewhat organize them. Every person can do it differently. It doesn't really matter. But I highly recommend when you start cropping and grabbing these pictures that you label them. Don't call them untitled 1, 2, and 3. That'll be a disaster. So for example, here with Chaim Bank, I created my own little system where this is the ID number in my genealogy software, surname, given name, and where I got the thing from and some kind of ID number. And these do need to be PNG or JPEG files. Here's another example from Yad Vashem, as we talked about earlier, an amazing collection of testimonies here. This is for a Gittel Alvais, and you can see, again, there's a picture in the corner of the testimony. You will see this all over Yad Vashem. And what I do is I simply go and crop this picture. I save it. This happens to be a JPEG. And again, I'm just using my same convention. I'll give you another piece of advice. When you're naming these files, very important, don't use any special characters. Don't use ampersands, parentheses, things like this. A lot of computers will really not like that. I highly recommend dashes are fine, underscores are fine. Even spaces can be a problem, but just use something that makes sense. So what I do is I just gathered as many pictures as I could of people that I knew were from Mielec, because what I wanted to do was tell the computer, these are all the people I know were from Mielec. These are people that I know Mielec, I don't know who they are, and let's see if we can find a match. So for example, another source would be a Yisker book. Tons of photos there. Here's another example where when I was in Mielec, one of many times I was in a local museum, and these were applications for ID documents, 1935 to about 1941. All local Jewish residents were required to have an identification paper. This was actually before 1939. So you can see here, I'm using a different convention here. I use underscores and no spaces. It's just another way I was doing it at the time. And again, the idea is you just take the document, crop it, and get one face per document. And by the way, you don't need to crop it so tightly. You could even leave it like this. It really doesn't matter. And so the idea is, again, from this step one of this gathering faces of people that you know, you should gather a large collection. You can see here I have over 860 faces of people I know. You can see here from Horowitz to Franzel to Wald to Blumenkill, so on. And so the more you have, obviously, the higher likelihood you're going to get a match when you give the computer a face you do not know. That's, I think, fairly obvious. So again, super important to go and just gather as many as you can from as many sources as you can and organize them in some kind of way that makes sense. The next step is to deal with the photos of the people you don't know. And you're going to really approach it in the same way. And I'm going to show you how I did it with this photograph. So again, this is the original photograph I started from Mielec, Poland. And what I'm going to do is I'm going to make copies of it on my computer. And if you don't know how to do that, it's not very difficult. Different computers do it in different ways. I'm using a Mac, and so I use a program called Preview. I make copies of it and I crop it. And what I'm doing is basically creating cropped headshots. And you can see you don't have to be so crazy about getting the exact face. You can see this very cute little kid in the bottom here. You can see I even have somebody else's feet in the background and a chair. Doesn't really matter. Doesn't really matter. The important thing, I even have a piece of this child's face in here. It doesn't matter. The software that I'm going to show you in a moment, what's important is that it will always take the largest face that it sees. So it looks at how much area this face takes up. It says this child's cut off. It's not going to look at that one. It's going to grab the largest one. You don't want to send it this picture here on the left because yes, maybe it's the man, but it's borderline in the computer. It's not a good idea. And then here's the fun part. So the way I did this a year and a half ago and the way I still do it is I actually don't do the facial recognition myself. I leverage a service that comes out of Amazon Web Services, AWS, very popular cloud computing platform. Those of you in the audience who may have a data science background or any kind of IT background, I'm sure you're familiar with AWS. It is by far the most popular cloud computing platform. Apologies if you work for Microsoft. My guess is it's still the most popular. And so what we're going to do is we're going to use two little pieces of Amazon Web Services for this project. On the left-hand side, we have a little picture of a bucket. And this is just cloud storage. And I'm going to send all these pictures into this idea of a bucket. That's what they call it. And you put all the pictures in there. And then I'm going to send it to this special algorithm called Recognition with a K. That's run by Amazon Web Services. Again, I didn't program it, but what I was able to do is figure out a way to go and send pictures of genealogical importance and be able to go and use this to go and find hints in a family tree. So you can sort of, the idea here is I have a computer, I send these pictures, they go and analyze them, and then I sort of look at the results. How do I do that? Well, I send this picture off to Amazon Web Services, and Amazon Web Services is going to actually go and look at every face, and it's going to identify, first of all, what we call this bounding box. That's this red box you see here. What it does is it looks for a forehead and the sides of the face, and it draws literally a box around the face. And you might wonder, how does it know? How does it know where the face is? Because it's a computer. And the answer is it's really quite simple. You see, computers are not very smart. So what you do in machine learning is you go and have a whole lot of real people look at thousands of pictures, volunteers, or you pay them by the hour and this kind of thing. And you tell them to go and take their cursor and draw a box around any given face. And what they do is Amazon Web Services paid lots of people to go and do this very boring job, which is to draw boxes around faces over and over and over again, thousands of them. And then eventually the computer starts to quote unquote learn what a face is. Maybe it's a bright area with sort of a jagged part that forms a hairline. It starts to recognize curves that must be ears and this kind of thing. So it eventually quote unquote learns. In the same way, a bunch of other volunteers or paid employees will go look at, again, thousands of photographs and use their mouse and click on the left eye and the right eye and the bridge of the nose and the tip of the nose and the left of the mouth and the right of the mouth. And these are called landmarks. And again, these were done by humans. And then once you tell the computer 1,000, 2,000, 3,000 times where the left eyeball is, eventually it says, oh, that must be the left eyeball. And this is how machine learning works. It's really not very smart. I always say it's a little similar to training a dog. When you send it to Amazon Web Services, you're going to get a response. Now, a lot of this is very techy and code looking. Don't be intimidated by it. It's really not that difficult. It's just this is the way computers through these things called APIs talk to one another. This particular format here with a lot of curly brackets is called JSON. It's a particular format of data, what we call semi-structured data. But what you can see here is that Amazon Web Services recognition is giving me the width and the height and the left side and the top of this bounding box. Now you might notice these are all numbers between 0 and 1. That is correct. It gives it as a ratio of the total height and the total width. So for example, the top of this person's face is approximately 25% down from the top of the picture. So you can imagine this is maybe the full length, maybe 1 inch or 2 inches. And to say it's 1 inch, this would be 1/4 of an inch from the top. It's saying here that it found the face. This search face confidence says that the computer is 100% confident that it did find a face. And that's very important when you see what goes on. However, it says in here, face matches. When I tried to match it against all my known pictures, it gave me just empty brackets, and that says no match. Let's look at the mother. So this is the mother in the photograph. And once again, Amazon Web Services goes and takes this picture and then looks at the same coordinates of every other picture that's in this, what we call a collection of photographs of these people I know, and we get a different response. You can see here that Amazon Web Services, again, gave me where this bounding box is. It gave me a searched face confidence. That is, how confident is it that it found a face? It's virtually 100%. But as opposed to last time, it found a match. And you can see it here in these hard brackets. You can see it very clearly. It found a match with a similarity index of 97.7. This is an index. I won't go into the mathematics and the data science of it, but it's a cross similarity index. How they actually compute it is proprietary. Amazon Web Services doesn't tell you, but I have a pretty good guess on how it works. It assigns this face a particular ID, and it gives the bounding box of the matched face it found, the image ID, and most importantly, and this is what I was telling you earlier about naming your files in a good way, because now I can know immediately which photo it matched it with. It matched this woman's face, whom I did not know, with a woman named Rivka Gross, who I did enter prior, and whose face Amazon Web Services was able to recognize as a face with 99.9% confidence. And again, don't be confused between similarities and confidences, as you can easily be. The confidences are the confidence that the algorithm recognized the face. The similarities are how similar are these two faces to one another. but 97.7 is very good. And I'm going to show you in a minute, and you'll probably hopefully agree that this is definitely a match. So again, here's the mystery woman, bounding box, and there's the match. And I'll let you stare at that for a moment, because it's pretty amazing, I think. First time I looked at this, I almost fell out of my chair. I said, that is incredible. If you look at it, that is absolutely the same woman. Different hairstyle, different time when the photograph was taken clearly, but if you look at her nose, you look at her eyes very carefully, she's slightly cross-eyed. You can see her what we would call her left eye, but it's actually in the computer we'd call it her right eye, is slightly off center from her left. You could see the mouth shape is the same. And by the way, you can notice, by the way, the crop of this picture is not perfect, nor is really the perfect to have fantastic resolution, but the algorithm is able to detect this. It's incredible. Every time it happens, I simply just sit there and say, wow, that's incredible. And so where did I get this picture? This is from this passport application for Rivka Gross. And then where did I go from there? Well, I went back to the vital record, just as we would do as good genealogists. And I said, aha, this is Regina Shapira, or could easily be Rivka. Rivka and Regina, easily the same name. Aha, now I have her birthday. Yes, that makes sense. And in addition, I have all sorts of other information here. So Regina, and then I have also this naturalization date here of her husband. And then I start to go and do what I would consider to be traditional genealogical research. I go back to records. So the key thing is that the facial recognition, you don't want to do it by itself. You want to do it in combination with very traditional records. So for example, this is the ship manifest that I found very easily. Once I had a hook, once I got through this brick wall, the rest just follows like a normal research. So I saw immediately, aha, the date's right. This is almost 6 months later. This has got to be it. Regina Shapira. Oh, and then I get the kids' names. Oh, look at these ages. This looks very interesting. By marriage, aha, husband, Mendel Shapira, 51 West 39th Street. Anybody at 51 West 39th? It's probably a nice place. Mendel Shapira here. And I can use traditional vital records to enhance my knowledge of what's going on with this family. But what got me started was the match between the passport photo and this unknown woman. So once again, once you have this information, you can break through that brick wall and start building your family tree. So I now know this is Rivka Gross, who married Mendel Shapiro. I know this is Celia Shapiro. I still don't know who the kids are. But then I did more research, again, more vital records, and you can actually go and build a family tree. How did I do this? Again, I started with photographs and facial recognition. All I had to do was get one, and then I'm sure you're aware, once you have one, you can really keep going. It's quite an amazing thing. So I want to talk about a second example. So this is an example a little different where I'm not starting from nothing. I'm starting from an initial document with a photograph. But I don't really know enough about her. I want to know her parents, and I want to know more about her family and where she was. All I have is this one document. So this is Sprinza Geminder, born 17th of November, 1916. And there's a picture of her. It's stamped 4th of February, 1942. I don't know much else. And furthermore, I have another problem, which is that the ink stamp is actually cutting across her face. And you can actually see this in the original document. And if I zoom in, you can see it more. And this could be problematic as far as facial recognition is concerned. My concern was that the computer, which again has been trained on faces without ink stamps, would be unable to find the face, seeing all of these dark pixels inside of a face. So what I decided to do was, when I ran it through the algorithm, indeed, I did not get a good confidence level that the algorithm actually was able to find a face. It was disturbed. It got distracted by this ink stamp. So what I did was I really used some very, very basic Photoshop skills. I didn't even use Photoshop, just as we would say, I smeared it a little bit. And you can see, poor Sprinza, I'm really sorry. You can see I really didn't do a beautiful job here, but it doesn't matter. And this is really the key piece, is that you don't want to put this on the family tree, but the computer is just finding landmarks. It just needs to find the eyes, the nose, and the mouth. So you can see I really enhanced the contrast of her lips here so that it could find the edges of the lips, because it's looking at the geometry of the face. So it's not a beauty contest, but this is a nice way to go and deal with images that have ink stamps on them for the computer to do it. So once again, once I was able to do that, the computer did find a bounding box and it did find a match. And you can see here that this is the match it found. And again, I'll let you stare at that for a moment because it's really quite incredible. At least I think it is. And what's furthermore quite interesting, if you look and you think about it a little bit more, of what the computer was able to do is that this picture here on the upper left, and all of the pictures I showed you previously, all had faces towards the camera. And this face here is not. She's looking a little bit off to her left. And what's very interesting is that recognition, AWS recognition, is actually able to find the various three-dimensional axis that this face is looking in with pitch and yaw, and it will actually give you those variables. It will actually virtually rotate the face so that it faces forward in order to match it with other people. It's really quite incredible. And then again, once I have that match, then I can go to the vital record from which it came and gather a lot more information about her than I had before. I now know she was in Krakow. We had witnesses who knew her, maybe friends, maybe family. I also have proof that I did find a good match because I find the same name. We're very close, almost the same birth date. And she's single, so Geminder's the maiden name. Again, you would use what I would consider to be standard genealogical research, but the hook into the door was the photo. Let me show you one more example before I go to the live demonstration. This is again, these are all true stories. So this is a photograph that I found in Yad Vashem, and it's not a photograph where I knew nothing. It's not a photograph where I'm trying to enhance information, but it's another kind of mystery. And this is a photograph from Yad Vashem. Was submitted by Avraham Klagsbrunn, who was a Holocaust survivor, and he wrote on the back some information. So I was able to get some information from this picture. So if I just zoom in a little bit, you could see here, for those of you that can read Hebrew, so basically this is Necha Klagsbrunn, says she's 18 years old at the time this photo was taken. And if you read the next couple of lines, you'll see that it is her sister, Shendel, and then there's a Reitzel, which I believe says it's her friend, some kind of friend of the family. And then Abraham sort of stops. I don't know why. Maybe he didn't know the other people. Sort of surprising. Maybe he just stopped. I don't know. These are always the mysteries of genealogy. But he stopped. There's no other information on this photo. This is Avraham Klagsbrunn and his address and so on and so forth. And so you end up with mysteries here. So my question here was, can I start with the information that's on the back of the photo, use facial recognition to fill in these gaps? And that's what I tried to do here. Again, first thing I do is I take that picture, I make a lot of copies of it. It's very easy on a computer, and I crop them one face per file, and I name them in a way that makes sense to me. So you can see here, I name them. Sometimes when I don't know the person, I don't like to use special characters. Sometimes I'll use the letter X for unknown person, this kind of thing. And immediately, the computer came back with two matches from my collection. It found the bounding boxes, and with the first match, it matched the person in the photograph with this, again, identification photo. And again, I find it incredible. That is absolutely the same person at a different point in time, clearly. But definitely an absolute match. Turns out this is Moses Hirschthaler, 6th of October, 1905. This photograph was taken in 1939. Clearly, this photo was taken before 1939. You could see the age difference here. And then what's even more interesting was that these two identification documents that I found that were matches were were given on the same day, 10th of June, 1939, and these two people are in the photograph. So this bottom one is Kayla Fowler, 3rd of July, 1909, from the same series of ID photos taken on the exact same day in 1939. So this, in my mind, is enough evidence to very clearly say this is almost certainly a husband and wife. My guess is some kind of engagement picture, something along those lines. I don't quite know. And I now know who these two people are. And I can start to fill in the gaps. very clearly, this is Kayla Nate Klagsbrun. And you might ask, how did I get their ages? Well, here's the thing. I know the photograph had to be taken before 1939. If I just go back for a minute. And I know when these two were born. So here, and I know that in the back of the photograph that she was 18, she was 20, she's clearly older. So, you know, if you guess she's something around 21-ish years old, and you know, for example, again, if I go back, if she's 21, that makes him a little 4 years older than her. Again, I'm guessing on the 21, but she definitely looks like an older sister to me. That puts Moses around 25 years old. And then all I need to do is, of course, I know when Moses was born. He was born in 1905. And I can easily just do the math. So now I know when the photo was taken. I know rough birth dates of almost everyone in the photo. I much more information about their relationships. I still don't know everything. I'm guessing this is the mother. It's got to be. It even looks like her mother. Still don't know who she is to this point, to this day. But I have a lot more information than I did before. A few more slides, and I want to go to this live demonstration I talked about earlier. So the algorithms I'm using with recognition are what we call pre-trained models. As I explained earlier, the way Amazon Web Services, and by the way, Amazon Web Services is just one of cloud providers that do this. You can do the same thing on Azure. You can do the same thing on GCP, Google Cloud Platform. And they do virtually the same thing. But the way they were done is, again, they had humans going and drawing boxes and pointing out eyes and noses and mouths on people from present day. And so the pros of this process is that it's relatively easy to use. It's very inexpensive. But the cons are, this was not trained. The model, the fine noses and mouths and hair and this kind of thing, were not trained on Jewish ancestors. And so you do get false positives and false negatives with this methodology. So I just want to be very clear. It's not a perfect tool by any stretch of the imagination, but it is an amazing thing to do. And when I say very inexpensive, I mean very inexpensive. Most of the time it's free. If you're just using it a little bit here and there in your own family, I'm sure you won't pay a penny. I use it for thousands of photographs every month. I think my bill is under $1 every month. It's very, 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 very inexpensive. But the ideal thing is actually to build what we call a custom trained model, which would be to actually take humans and train it on Jewish ancestors, and you would have much better results. So the pros would be, it would be a trained on a specific set of images that we're interested in. But on the downside, this is very hard to do. You need a data science background. You need to know how to use TensorFlow or Keras or whatever these things, various pieces, SageMaker and this kind of thing. And it also takes an enormous effort. We would need to pay, or us ourselves, need to go and train a whole new model. We would need tens of thousands of images. And again, draw bounding boxes and eyeballs and this kind of thing. And it's just very time consuming. So in summary, before I get to the demo, the key thing with this facial recognition technique is that it's not a panacea. It's not going to solve all your family history mysteries, but it's just another tool in your toolbox. Besides traditional research, DNA, which is a very exciting avenue, online search, human experts, to me, facial recognition is just another tool in a genealogist toolbox. Okay, let's do a little bit of a demonstration. And so I'm going to get out of PowerPoint, so I apologize if my screen's going to be a little weird. Nope, come on, Scott, there we go. So I want to actually do a live demonstration. So right now I'm in Google Chrome, and this is a very small website that I built myself. Anybody is welcome to use it. And matter of fact, the code is actually publicly available. And this is my website here, ancestorfacematch.com. And what I did was I decided to just do a very basic website. I am not a web developer. I'm sure there are many of you in the audience who are. And God bless you. I am not a very good web developer at all. But what I did was I was able to put this technique in a very simple way to a website that will do these queries with no coding. And what I did was I started with my Mielec face collection here. And the way I built this site is pretty straightforward. Obviously, you just simply choose a file. So I'm going to show you the same thing I just showed you earlier with the slides. So I'm going to choose what I call the mysterious Klagsbrunn woman. Go away, zoom. There we go. And so you can see this is the picture that I've chosen. If I click submit here, you could see in a nonce, it actually has the face that I had previously uploaded. Here's my file definition. Again, if I mentioned earlier, very important to label those files well with a similarity index. Pretty easy to use. I'll do the same thing with Moses here. So again, here's the mysterious man in the photograph. I simply click submit, and there it is. This site is free to use if you happen to have family from Mielec, Poland. Pretty unusual, but I know there might be some people who do. I do have some other collections that I've been working on, and this is where collaborations start. And I'm going to show you some collaborations that I've been working on here. So I'm working with some folks who are working on Kremenets in Ukraine. I also have a bunch of photographs from the U.S. Holocaust Museum. And then lastly, and the one I'm most excited about is a partnership, not really a partnership, I'm just helping them really. The folks that are working on Lublin. And for those of you that have any family in Lublin, this is an amazing website. This museum in Poland, in Lublin, that has the 43,000 project. And this is a project where they are looking to create a database of all 43,000 Jews that lived in Lublin prior to the war. The challenge they have, of course, is they have many, many thousands of photographs of Jews, but they don't know who they are. But they have many other photographs of people they do have. So this is exactly what this facial recognition tool can be used for. So I'm going to show you a very quick example of that. So for example, what I did was I took this picture here of Sussel Urman here. And I saw that they didn't have, they only had this one picture. And what I did is I grabbed a whole bunch of pictures where they didn't know who it was. And I did the same thing. So I'm going to choose Lublin here. And I'm going to choose Zissel Urman. And I just do the same thing. And by the way, you'll notice I didn't crop it very hard. Doesn't matter. And there it is. So what it did was, and I have this code here, and this links to a photograph of another picture of him that they have in their collection. So what they're starting to do is use this technique to start to identify Jews in photographs that they found after the war and try to go and identify every Jewish face and match it for the person that it really was. I think it's a fantastic project. Here's another example from Lublin. I'm going to go to Leib Zorman here. And again, if I show you online, so again, this is the picture from the site here. They don't have any other pictures of Leib. I think he looks a little bit like Brad Pitt personally, but anyway, moving on. So if we go here to Ancestor Face Match, and oh, I already did him, sorry. And I simply click submit. Nope, maybe I have to reload here as I'm yakking away here. Let's choose this file here. Let's choose Brad Pitt. And there's the match. And so if you look at these two pictures, it really is incredible what it's able to do. You'll notice that the similarity index drops a little bit. That's not terribly surprising. You can see it's not quite the same kind of match. My general rule of thumb is I don't really look at anything seriously below, certainly below 80%, even 85%, just working on this for the last couple of years. Before I move on from this website and just finish the demo and a couple other things, for those of you that do know how to code with JavaScript and HTML and CSS, the code is publicly available on GitHub. In addition, I'm working with my company as a free opportunity for genealogy researchers to do what I call a code-free version of how to do this. And so I work for a company called RapidMiner. It's not a sales pitch. It's free software for you anyway. That we're going to be publishing a drag and drop operator so you don't have to know how to code. And I'm just going to show this to you very briefly. It's not been released yet. We've just been working on it the last couple of pages. I won't bother with what this platform, this is RapidMiner Studio. For those of you who are interested, all you do is simply drag and drop these little operators here on these little wires. And the nice thing is you don't have to know how to code. You don't have to know JavaScript or anything. All you do is simply go, and we'll do the same example here. I'm going to go here. I'm going to do Kayla Thaler here. And we built the operator to simply answer this one main question, which is, can we match two people? So I'm going to go and put Kayla's one picture here, the mystery one here. And you just press go and you get a similarity index. So it's another way to do what I just showed you without coding. I wish there was an easier way, but right now the technology is so new that there isn't. I'm going to go back to my PowerPoint. I'm looking at the time, and I do like to be on time on things. So about 5 more minutes, and then we'll open it up for Q&A. I'd like to go back to my PowerPoint here. And I'm going to go and back to here, hide this silly thing. And I'm going to play from my current slide. So that was my demo. I want to talk a little bit about ethical considerations. When I started this, I actually was very hesitant to even move on. For those of you, and I'm sure many of you, this is an immediate thought. This can be easily used for nefarious purposes, could be a very much an invasion of privacy. And so I think we need to make sure that we use these technologies in a very thoughtful and ethical way. I would rather not use the technology and protect people's privacy than use it and take that risk. So, for example, could people use this software to identify Jews for anti-Semitic purposes? I think it's absolutely feasible. So we have to be very conscious of this and the use and misuse of this technology, in my opinion. So again, could this exacerbate Jewish facial stereotypes? For example, it's looking for a nose or ears or dark hair or something. So you can imagine every possible trope or stereotype about Jews, and this technology could, particularly in this day and age, if you look at the ADL and other things and what's going on in the world, the last thing we want to do is make things worse. And then you get these kind of questions. Can we use this in my grandson's bar mitzvah? And the most requested feature that I get, which I have not done, is exactly what I showed you earlier, which is I get people that write me now all the time and says, I want to just do this for my own private collection. I just have 2 pictures and I just want to see if they're similar to one another. And my answer is no. I refuse to add this to my website. I will not add it to my website. And the reason is this, because currently with the technology, there is no way for me to prevent people from doing the exact same thing with living people. And I do not want somebody on the streets of New York or anywhere else in the world to take some snapshots of people on the street and then cross-reference it against God knows what. And all of a sudden you are in a huge invasion of privacy. The technology is totally feasible. If you read news about China and so on, it's already there. I just refuse to be a part of it. It's a Pandora's box that I personally will not open. But as I showed you earlier, if you have this project where you want to do genealogy and you just simply want to compare 2 pictures because, Tanta Sarah, Tanta Gittel says that this is your great grandfather, and then you have another picture of great, it doesn't look like him. Yes, it does. No, it doesn't. So you can use the code that I showed or the company software, RapidMiner. I'll show you at the end of this where you can get that information. Actually, it might be coming up very soon. There's no charge. It's free download. There's no charge. We only charge big companies. So if for regular folks, it's what we call freemium software. It's like Google, it's like Gmail basically. And that's really my answer now. And by the way, these things on RapidMiner I showed you were built yesterday. So actually I went out of order. So again, the demo of comparing faces in RapidMiner I just showed you. So I went a little out of order. I apologize. This is not yet released yet, but I'm going to show you a link. You can at least read about it and just check in and write me a note, and you can do it yourself. So how do you do that? So what if you, and I'm just going to get out of my slideshow because I just want to show you and point out, oops, sorry about that. Yeah, let me go back here for a second. Come on, Scott. There we go. So on this page, again, ancestorfacematch.com, at the bottom, I hope I pointed this out. If you're a coder, you can just grab the code on GitHub. It is under open source. I am giving this away for free for the world. People have said, oh, well, you should sell this to a company. I thought about it, and nah, it's not me. Sorry. So it's free. You can have it. If you're a coder and you like JavaScript and you like HTML and CSS, have at it. Hopefully you'll make it better than mine. If you're not a coder, if you don't know how to use computer programming, particularly JavaScript or whatever, my company is going to release this extension as a courtesy, basically, for the genealogy community. It's coming soon. I tried to get it launched for today, but it wasn't quite there. And then I have a step-by-step tutorial that I wrote a few days ago here that shows you literally click by click how to start an account with AWS, how to go and build all these things. and I tried to include as many screenshots as I can. So I really tried, drag and drop. I tried to make it as straightforward as I possibly could. So, thank you, Zoom, for just making my life difficult. So just, a couple of quick things. So if you are a computer person, this is my tech stack. You can see in the beginning, I really started on the command line and then moved to these SDKs out of Amazon Web Services. If you don't know what an SDK is, just tune out for 30 seconds. So this is my tech stack on AWS. Again, working in AWS Cloud, I use Cognito as the authentication engine, and then the SDKs. Originally, I did this from the CLI, from the command line, but right now I'm using Amazon S3 and Recognition, and that's what the website is doing right now. So right now, this is a WordPress site with JavaScript. I'm in a virtual private cloud using Cognito for the authentication, and then just using S3 and Recognition. So if you have no idea what I just said, you can tune back in now because I'm going to go on to the next slide. So this is my current projects. So again, I'm working with this museum in Lublin, which I'm very excited about. I'm working with my company to try to produce more of these little operators, we call them, so that people that don't know how to code can do this themselves. I'm also working with JRI Poland and Robin Magid, who, for those of you who are familiar, JRI Poland has the next generation site, and I'm hoping to help them do a lot more with their photographs as well. That is the end of my presentation. They told me to stop at 3:45. It's 3:47, and if you take away my intro, I'm right on time. So I'm happy to stop this presentation. I'm going to open up my Q&A, and I think my moderators are going to help me maybe.
Okay, we're back.
3:47.
Right. Yes, very good with the timing. So now I will read you a selection of our questions from the audience. I will do my best to group them by theme, because there are a lot of questions that are sort of similar to one another. And also I will do my best not to ask you questions that you've already answered.
Not a problem. Not a problem. Go ahead. My mind is
right.
Go for it.
So there are a lot of questions. We will try to answer as many as we can today. So you just mentioned it briefly at the end about how you can literally use this to compare two pictures, correct? So there's really no, in essence, there's no size limit in terms of how large a photo collection you want to assemble. But that depends on your purposes, correct?
Correct. Again, the way I had originally built it, a year and a half ago, was this idea of helping the museum, and so I started with this idea of collections. So Amazon Web Services Recognition, really, most of the time you work in these things called collections. So a museum collection or a collection from yourself, from your family. The size of the collection isn't important, but of course, the more photos you have in your collection, the more likely you're going to have a match. But after I started getting email after email after email, just nonstop saying, I don't want to do collections. All I want to do is see, I have two photographs and I want to see if it's the same person. And that's when I worked with some friends of mine in my company, and we were able to come up with these tools to let people do that. Again, I do not want to do it on my site. I find that to be a very risky thing. But if you want to do it yourselves, then that's, I guess, not my problem. But anyway, so the tools, we tried to get it published for today, but should be published, I would say, in the next week.
Okay. There are a lot of questions about quality of photos. So again, you're suggesting that the quality doesn't influence it that much unless there's something that very clearly obscures somebody's face.
Yeah, it's really amazing how poor quality you can have. Very grainy photographs seem fine. One time I put a photograph in that actually had another face in it. I didn't even realize it. And it was a picture of a woman that was on a calendar on a wall in the back of the picture.
Oh, wow.
I didn't even know she was there. So no, it can be pretty grainy, but just think the way a computer does. If you can see the sides of the face, top and bottom, if you can see eyeballs and a nose and a cheek and mouth, it's probably good enough. You'll find out immediately. You'll send it and they'll give you a confidence value.
Okay. Oh, this is something that's come up a number of times. How good is it at identifying photos of an individual at different ages?
It's a great question. I'm glad somebody, I don't know who asked, it's a great question. The answer is it's obviously much better at middle-aged adults than anything else. Why? Again, as I mentioned earlier, that's because Amazon Web Services, when they built this engine, they didn't have genealogy in mind at all. And they tended, who are the people that program computers? They're people around my age, or probably a little younger, but anyway. And that's what they did. As a matter of fact, there's also probably a very large racial bias. If you are dark-skinned, I probably will not do as well a job. It's similar to what we see actually with using this technology in the present day. There's definitely a racial bias. There's definitely a bias in age. Babies, it's almost impossible. Small children, a little better. Adults about my age works very well. Very old men and women, particularly old men with long beards, it all thinks is the same. So again, this was the disadvantage of using a pre-trained model versus what a custom trained model where you could train it purely on Orthodox Jewish men, and then it would be able to tell the difference.
Okay. So with that in mind, for if people want to build their own private photo collection, would you say it's advantageous for them to put in the same multiple pictures of a person at different ages?
Yes, if you have them, absolutely.
Okay.
Just make sure that when you label them in a way so that when the results come up, you're like, oh yes, okay, that's who that is. The labels of the names can be quite long, by the way. You can put 70 characters. So you can write this, just don't put any special ambersands and this kind of thing.
Okay, cool. Okay, let's move on to Amazon Web Services. There are a number of questions about that. You talked about the cost being incredibly inexpensive. You mentioned that there are other services like that. Is there a particular reason why you chose Amazon Web Services, or is there some place where people can go to find more information about the differences between these different softwares?
It's another great question. So the reason I chose Amazon Web Services is that, first of all, it was the first cloud provider I used, so it was a comfort level for myself. They were really the first. Azure and GCP really came later. And so they're sort of the big player, but it's more of it's just personal preference. There's really no other reason. I am sure Microsoft Azure's results are probably similar, but it would just take a learning curve on my part. I'm very comfortable in that ecosystem. But I have not compared. A lot of people had asked me to compare the performance. I'm just one guy doing my best. I have not found the time.
Do you know if anybody else has done some kind of comparison?
No.
No. Okay. Let's see.
But I would love to see it.
Oh, there's a lot of questions about when you're using Amazon Web Services. Is it just comparing your let's say your mystery photo against photos that you've, let's say, given, or your bucket, or is it also comparing it to other people's buckets?
No, it's completely isolated. It's complete. And Amazon Web Services, and by the way, same thing with Microsoft Azure, same thing with Google Cloud Platform. These are the same cloud providers that major companies use. Their security is extremely tight. Matter of fact, if you're in the medical industry, they're all HIPAA compliant and this kind of thing. So the security is extremely tight. And no, nothing is stored on anything that anybody else in the world can see by default. You can make it public if you really try. But the default on all these systems, you have your own complete little private file cabinet, basically. Everything is completely to yourself.
Got it. So basically the only way that people could potentially compare their mystery photos to a quote unquote public pool of photos would be a project like your Mielec project or the Lublin project or other projects that other institutions might be working on.
Yeah, I mean, I think that's what Robin Magid and other folks at JRI Poland are thinking about. And other similar I think there's a lot of people now that are sort of, and yeah, exactly. So my guess is that we're going to see in the next year or two, we're going to see these major Jewish Gen, JRI Poland, these kind of organizations start to poke around. I've already heard bits and pieces. I know that the company MyHeritage is working on similar things. So these are the places where you're going to start to see these technologies for sure.
Okay. Let's see. So now there are a number of questions about other potential uses for this kind of
Yeah.
software. So we talked about, or you talked about comparing a photo of a mystery individual with a pool of faces to find a match for that particular individual, and how the computer rates a sort of confidence level to that. Do you think it's realistic in the near future that you could also train a computer to learn to be able to identify relationships between family members?
I've even seen it already. Yes.
Okay.
So quite often, if I put a face into my collection of photographs, it'll tell me that person's a match, but I know from my family tree that they're siblings. So
Okay.
it stands to reason, right?
Yeah.
Now the computer doesn't know who these two people are, but again, it just gives you a hook. So yes, it definitely identifies, particularly siblings or parent to child, grandmother. It just looks at the face. It's just looking at the geometry of the
Right.
face. And my family, we all have eyes that are like this, or ears that are sticking out, or whatever. And it's just trying to find similarities. So yes, I have found, but it doesn't tell you this is a sibling.
Right. It doesn't tell you exactly what the relationship is,
No, of course not. Of
but it
course not.
can kind of give you an indication of a relationship.
Yeah, I mean,
Yeah.
yeah, I mean, exactly. It gives you a hook, right? So then you
Yeah.
might go back to vital records. You might go to DNA. You might go talk to your great aunt Sarah.
Okay. Okay. So there's a couple questions about Google Cloud or Google Photos. Often the program will ask if two people are the same. So it's kind of already doing something similar.
Yes.
Do you know about the success rate of matching
No.
unknown family photos? Okay.
Apple Photos does the same thing. Google Picasa does the same thing. By the way, it's the same technology. So no, a lot of people have talked about that. The answer is it sounds similar. I haven't played with it. I'm sort of a geeky guy, so I did it the code way. But the only thing to be careful of with Google Picasa in particular is you need to really make sure you look at the EULA, at the end user license agreement. Make sure that your photos are truly private. I know with Amazon Web Services, other things that they do lock it down, but just please protect your family's privacy at all costs, please.
Okay. People have also talked about finding whether you can put in a descendant's photo and find out who their ancestor may be. But again, it's based on this sort of potential resemblance. And
it's
yeah.
not DNA. It's not going to tell you it's a second cousin 3 times removed.
Yeah.
It'll just give you a number from 0 to 100.
Right.
And you just got to go from there.
Okay.
Now, maybe in the future it'll do better. I don't know. And in theory, machine learning, from a theoretical point of view, if you trained a model that go, the parent, child, and you did thousands of those comparisons, mathematically, sure, it's possible. Do I want to do it? No, doesn't sound interesting to me. And it sounds very dangerous. No, thank you.
Let's see. Okay. A number of people have asked about ears.
Oh,
so
you like my ears?
So why is it that those bounding boxes are drawn without the ears? Are the ears not considered like a sort of identifying feature, or?
Computer scientists like straight lines. They like to keep things simple. A rectangle is a lot simpler than some crazy shape with ears. It's a computer scientist will go and try to simplify a problem as much as possible. And so maybe in the future they'll deal with more complex geometric shapes, but they're getting pretty far with rectangles.
Okay. Oh, interesting. What other factors do you think might throw off a potential facial recognition? Should we be aware of specifically the person raised? What about plastic surgery or
what? Did you get plastic surgery? What?
Or, well, this might be more realistic, historically speaking, facial disfigurement due to an accident or illness or whatever.
Sure. It's a very good question. And the answer is I can tell you that, for example, I could only tell you anecdotal evidence. I have not done any kind of rigorous study on this. I have a day job and I just don't have time for it. Somebody out there in academia wants to do a rigorous study, I would love to see one. I just don't have the time for it. If I had all the time and money in the world, do a PhD in it, great. I don't have the time for it. But I can tell you anecdotally, after doing this for the last couple of years, there's a lot more information that recognition does grab from the face than what I showed you. Actually pulls about 36 landmarks. It includes pupil location. And I have a hunch, for example, that it's able to discern, there's definitely a hereditary trait in Mielec, Poland of cross-eyedness. I've seen many, many, many children cross-eyed. So it's obviously there's sort of what you're talking about where, but it's looking at pupil position relative to the width of the eye. And I know for a fact it's able to detect that because it tends to match cross-eyed children more than others. But it's purely anecdotal. I have no scientific evidence or any rigorous study to back that up. Otherwise, I could say as far as the quality of the photo, which is the other part of your question, sometimes it doesn't like the photo and I can't figure out why. There's not enough contrast between the backdrop and the face. Sometimes the crop, if you make it a little tighter, I wish, the thing about these package services is that they're proprietary and the algorithms, I mean, I know as a data scientist how in general they did it. It's all published. It's all known science at this point. There's no great mystery how they did it. They used TensorFlow and, these things. But they don't actually open up their algorithm for the world to see, which means I can't go in and say, aha, that's why it didn't recognize X, Y, and Z. The only way you're going to know is by trying it yourself or building your own model. And then, of course, you'll know. Okay.
So a lot of people have asked about starting their own sort of projects. What advice do you have for that? Should they be joining some sort of organized effort like JRI Poland, or what are your thoughts?
It's a great question. So my initial thought is that I think I see the greatest value in this. And again, this could be a bias on my part. My opinion is as valuable as yours or as anyone else's. My personal opinion is that the value is in people who are coming from the same towns, for example. It's how often we do Jewish genealogy. So my family came from this shtetl and this kind of thing. And therefore you can sort of combine resources, but it's still private. Relatively private. Like, for example, the way I built my site is you have to put a photo up in order to get a response. And unless you're from this town, you could upload photos till the cows come home. You're not going to get any response. So it's relatively private in that way, even though it's a public site. So that was the way I chose to do it. And I think that makes sense. But that's not the only way. And again, the most number one request I've been getting ever since my article was published last fall was a much smaller scale. I have 10 photographs.
Yeah.
My grandparents say, this is Uncle Mutty, and this is Uncle Mutty. Can I have the computer solve this family argument? Well, first of all, not good advice in general to have a computer solve a family argument, but that's a different. But in more serious tones, that's why I asked my company if we could just help the genealogy community in some way with our own software, and these are the tools. That's why we built this compare faces. What we call an operator, so that any person, even not knowing how to code, can simply do this. I just don't want to do it. I just read the news and all this stuff going on. I'm like, Scott Genzer does not want to be a part of this. No, thank you.
All right. Thank you. Let's see. Okay, people have also asked a number of questions about which photos to collect. Beyond obviously people's personal family photos, do you have any recommendations for gathering a large number of photos, let's say from a particular town?
So public records, it's really, it's funny, if anybody's been doing genealogy, you think, oh, there aren't a lot of photos, but there really are. It's just that we as genealogists are so used to just not paying attention to them. They really are all over. The Yad Vashem is obviously a very narrow time frame. Obviously, it's just the Shoah and prior, but there are many public resources available. Old school, private, public, vital records often have naturalization papers in a certain period of time in New York have photographs. Some don't, some do. And by the way, don't worry about color versus black and white. I actually find the black and white photos, the algorithm does better than color. And it's probably because there's better contrast and so on. So don't worry, saying, oh, they're bad. Black and white works really well. And so, once this crazy pandemic ends, New York Public Library and other just normal resources, you'd be amazed if you actually start looking for photographs, how many you'll actually find.
Yeah, I agree. There's a lot more out there than you would think.
Yeah, we've just never paid attention to them. It's just it's just something that you just attach and you're like, oh, that's nice, and you put it in your family tree. Even in in companies, for those of you that remember Ancestry, I belong to Ancestry. They're expensive, but anyway, that's a whole nother story. But even on Ancestry, you notice the photos are sort of an afterthought. They're like a whole nother section of the software. They're not really the focus. And the answer is because nobody's been able to do anything with them. So my hunch is that you'll see more.
Oh, okay. So there are a number of people asking about your site and the tutorial. Can you post the link again in the chat box?
Oh.
And also, how can people find out when that new extension is going to be available?
So that is a fantastic question. I wish I had an answer for you. So we submitted it to product management today. So I mean, literally, a colleague of mine was just super kind and just he's a coder and he knows how to program, and I told him, I said, listen, I have this talk, and so I just want to thank him wherever he is. He's in Germany. Just a super nice. He did it on his own free time just to go for the genealogy community. So we're trying to get it done. With the pandemic, it just didn't get done in time. I will say, I'll tell you this, I will put it on either that tutorial page or on the site itself. I will put saying it's published, or you can just drop me a note. I would say at the latest December 1st. How's that? Absolute latest December 1st.
Okay.
It'll definitely be before then.
And that website again is ancestorfacematch.com, right?
Correct.
Okay, I can type it into the
Scott Genzer's little domain. It's got one page. That's all it has.
Okay.
Yep, there it is. Ancestor, that's it. Yep.
And let's see.
And if there are other people who are organizing, other communities, like you saw, I have Kremenets and I have Mielec and I have Lublin. If there are others who are coordinators of these communities, please reach out. I'm happy to add you to the list, and put your photos onto my site. I'm happy to host it. It's not very expensive for myself, and I'm happy to do that as well. But please, not individuals. I don't want like the Schwartz family. That's just going to get insane. But if there are people that are organizing communities, especially by towns or by museums or something like that, please reach out to me directly.
But if somebody has a collection of photos from Mielec, should they get in touch with you?
Yes, today, okay. Please. Yes, please.
Okay. Somebody actually did write that, so.
Oh yeah, no, it's my full-time hobby. It's a little obsessive, as I think.
Let's see.
I see a bunch of questions at the top of the Q&A about sort of the, whether it's a JPEG or a home computer.
Oh yeah.
Computer is needed. Should I answer those?
Yeah, sure.
So yeah, I see it at the very top of Q&A. You're the one scrolling through 70 of these. I see a question about JPEG versus a PNG file. A PNG is always preferred. That's an uncompressed file. JPEGs are always compressed. So if you have a choice, PNG is usually better than JPEG, although it usually doesn't matter. But there's just some compression there. And as far as what kind of computer, it's fine. If you're going to use RapidMiner, you might need a little bit of RAM, but it's fine. Students use it and they're poor. So if students could do it on their computers, then anybody else can as well. Somebody asked about a handout. So I don't generally give away my slides, because if you have the slides, then they don't really tell the full story. But the copy of Avutenu, anybody that writes me, I'm happy to send you. Avutenu has given me permission to send the copy, or I can send it to Center for Jewish History, and you can put it somewhere if you like. So the article from Avutenu is free to be published anywhere.
Oh, okay. Oh, and I just want to add to that this program is being recorded, and will be available on the Center for Jewish History's website and YouTube channel, I would say within a month. So stay tuned for that if you want to review this or if you missed any parts of it. And I apologize, somebody mentioned that I haven't been publishing the questions as I've been reading them, which is true, so I'm going to try to do that as well, as much as I can right now. Okay. People have been asked there are a number of questions about what you recommend for simply, I guess, uploading photos, cropping them, things like that. Do you have any
Yeah.
particular
There's so
recommendations?
many tools out there. I mean, I use a Mac, so I use Preview. There's so many different tools to crop photos. Honestly, you could sit there with your phone and put the photos on your table and
Yep,
crop them with your phone.
that's true.
Honestly, it doesn't really matter. And the cropping doesn't even need to be perfect. So don't get crazy about it. You can literally do it on your iPhone or anything. You could literally just print them out and put them on the table and print them. Don't get crazy about it because it's just not worth your time. The important thing is volume, obviously, because you're playing a game of match. You're playing a game of, like you used to do with the kids, right? Like, oh, there's a match of elephants. And so the more pictures you have, obviously, the more likely you're going to get a match. But it's not that important. And every modern piece of technology that takes pictures like this will be fine. It doesn't really matter. There's so many pieces of software out there. For this purpose, whatever works for you.
Privacy question, actually.
Good. I'm happy to hear that. Good.
Let's see. If if you use AWS, and recognition and the recognition software, would the person lose their rights or ownership to the images themselves?
No, not
Okay.
according to the EULA of AWS. So, and by the way, this is the same for Google Cloud. It's the same thing for Azure. The not Google Picasa, that's a whole nother world. But Google Cloud Platform, GCP. So these are enterprise level securities. They all have what we call SOC 3 credentials as far as IT security. These are battle hardened. I mean, nothing's perfect. I mean, don't get me wrong. Nothing. One thing we know about this modern technology age is nothing is perfect. But I'll tell you one thing, and I tell you this as somebody that works in the industry. Your photos are safer on AWS than they are on your own computer at home. That I can guarantee you for a fact. And because, believe me, because the best IT people in the world are not in your house. They work for these companies. And the big Fortune 500 companies in the world, all the big banks use these cloud providers. And so if these cloud providers screw up, it really gets bad. So they have the highest level of security. Again, it's not perfect, but I guarantee you it's safer up there in these cloud providers than it is on your home computer. That's without question. Your home computer is usually your biggest risk.
Okay, so I think we will start wrapping up now.
Sure.
Just before we head out, can you please share your whatever contact information you would prefer that people reach you at?
Sure. Should I just share my screen with my last slide again?
Sure.
So how's that?
That's perfect.
So I'm going to go
Okay,
and
so you can
minimize this Q&A
see
screen.
Scott's email, his two websites, and Twitter handle, and GitHub, which is for coding. Yeah.
Correct. If you've never heard of GitHub, it can be a scary place. It's basically the world's largest repository of open source code. Actually, currently owned by Microsoft, if I'm not mistaken. But somebody correct me if I'm wrong. That's my personal email. Gmail. If I don't answer you, please be patient. I am not retired yet.
Okay. All right. I think you've given us a lot of food for thought. I hope that the people are watching today are inspired to either work on their own private photo collections and using this kind of software to help resolve your personal family mysteries, as well as hopefully even more so to organize into various public projects which will help your lawnsmen and your descendants for generations to come in resolving these kinds of photo mysteries, and also just honestly creating pools of historical photos from particular towns is an interesting endeavor on its own. But yeah, I'm so grateful that you agreed to come and share your knowledge with us, and that you're offering these tools for free to the genealogy community. So with that, I think I'm going to say goodbye to everyone, and hope to see you all soon at a future program.